everybody. I hope that you're having a great first day back. I'm really sorry I'm not able to be there with you. Trust me, I would much rather be with you guys than not feeling well. And I hope you had a wonderful break. Okay, let's get into a little bit of physics here so we don't get too far behind. What I've put up is a different type of problem for circular motion. It says, imagine a person in a car feels a force of 1,400 newtons when turning. The person has a mass of 63 kilograms and the car is turning with a radius of 11 meters. How fast is the car going? Well, with the equation that we have, centripetal force equals 4 pi squared mr all over t squared. We know some of the information, but not all of it. We would know what the force is, the mass is, the radius, but we wouldn't know the period, but we wouldn't want to solve for the period. So what we want to do is come up with an equation that involves velocity. So let's start back with some basics. You guys remember way back when we said that velocity is simply equal to the distance over the time it takes. Well, the distance to go around the circle is simply the circumference, or 2 pi r. Okay? And the time it takes to go around the circle once would simply be the period. So we now have an equation that says velocity is equal to 2 pi r all over period. Well, since we have velocity in terms of period, we can solve for period and then put that into the force equation and have a centripetal force equation that involves velocity. So let's take this equation up here, our centripetal force, and rearrange a little bit. Let's say instead it's centripetal force times t squared equals 4 pi squared mr. Then over here, let's do the same thing. Let's solve for period. We'd say period is equal to 2 pi r all over v. And let's plug this in over here. So I'd have centripetal force times 2 pi r all over v squared. And that would equal 4 pi squared mr. Let's expand this a little bit. So we're going to have force centripetal times 2 squared would be 4, pi squared, r squared, all over v squared equals 4 pi squared mr. Well, already we should be able to see that we are going to be able to rearrange some of this as well as cancel some of it. I see that I have a factor of 4 on both sides. I see I have a factor of pi squared on both sides, so they would cancel. Now I'm going to multiply both sides by velocity squared, so I would see fc times r squared equals mr all over v squared. And then, oh, I'm sorry about that. Not thinking. Multiply v squared goes up there. Then I'm going to divide both sides by r squared. I would be left then with a lovely equation that is force centripetal is equal to mv squared all over r. So all we've done here is come up with a new equation for our centripetal force. This one simply uses velocity instead of period. Force would still be measured in newtons. Mass would still be in kg. Velocity, of course, is in meters per second. And radius would be in meters. In the next video, I'll go through and solve the above problem to give us an idea of how to use this actual equation.